Okay, can you see the screen?
Yes.
Okay. So, hi everybody, I'm Lorenzo Bassi, and I'm a student and I'm attending a course at the Master Degree in Telecommunication Engineering at the University of Bologna. The network function that I designed and I'm presenting to you today is about OPC UA. This network function is not in the list of the suggested network function, so I think it is mandatory a little and fast introduction to make you understand what is really OPC UA, because I think that many of you probably won't ever heard about it. So what is OPC UA? OPC UA. First of all, OPC UA is a communication protocol. OPC was the first release of the protocol, and nowadays the last version is OPC UA. And its aim is to find a way to standardize the exchange of data and information inside an industry scenario. I do not want to enter too much in detail because of the limited time, but OPC UA is a standardized client-server architecture, and it is a vendor-independent platform. This means that the communication is independent from any programming languages or operative systems. And OPC UA provides a simple information model, but the operator has the possibility to design its own information model. So at the end of the day, we can say that everything is open, and is the operator that builds its own information model, object, methods, variables, and so on. Finally, for the discovery of the service inside the network, there is a discovery server. Through a publish subscribe mechanism, yes, and this is what I want to obtain. The OPC client server are two virtual machines, but instead of using a virtual machine for the discovery server, I used a different approach. This is the Mac architecture. We have all the Mac applications that are running and can register a service to the Mac platform or ask for some services. So I decided to take advantage from the Etsy Mac platform framework, following, let's say, a Mac-based approach. So client and server are able to talk each other, and this is done through a REST API post request to the application app instance ID services endpoint of the Mac platform. In this way, each Mac application can register a certain service, and in this case, the server. And in particular, the server registers the service, including some endpoints. I show in the figure the IP address and the port number of the service. Now it's the client that has to communicate with the Mac platform. So the client asks to the Mac platform, what are the endpoints of the server? And how can I reach the server? Because of the client needs to access to a service that is running inside the server. And the Mac platform responds with the endpoints previously registered by the server that are port, IP and port. And now the client knows how to reach the server. And after the connection, the client gets access to the wanted service. So this is the case scenario that I would like to implement in this case. Okay, but how Mac 011 APIs are implemented? This is the REST API post request that the server makes in order to register its own service. We can see that all the endpoints are registered by the server. We can see, for example, host, that is basically an IP address because it represents the DNS name of the service, and also the port number. Here is the code at the client side. We can see that the function starts sensing this one. search inside the Mac platform a service that is characterized by the OPC UA as a name, and be topic based as a type transport used by the service. Once the wanted service is found, the client is able to get access to all the endpoints. In this case, get access to the address, which contains inside the host and port number. After this, the client can connect itself to the server because he's aware of the endpoints that are registered by the server through the Mac platform. Okay. So I think it is the moment for Davide to share the screen.
Okay, let me find him. There you go, Davide.
Hi, you should see my screen, right?
Not yet. Let's give it a moment. Now, yeah, it's a bit small. I don't know if you can make it a bit bigger, the writing.
Mm-hmm.
Otherwise, we can see it. Okay.
So
yeah,
much,
perfect.
Maybe.
Okay.
Okay. Go.
Okay. So now I can show you the code to implement this scenario. I have 3 network services, a client, a server, and a network service for the Mac platform. The client and the server are KNF because they are handled by Kubernetes. First of all, let's launch the Mac platform. We launch the, okay, Davide, you can launch the Mac platform.
Yeah, I did that in advance because
okay.
Otherwise, maybe it takes some time, but
the execute. Yes. Okay. The Mac platform is made through an M chart that is located in a local repository, simply because we do not have enough time to translate it into a Juju bundle, and so also because we do not have a day 2 operation, and we do not have any day 2 operation that are related to the Mac platform. So that's because it is an M chart. Okay, then we can launch the server.
Yeah,
and
just a quick adding here. What you see here is a curl toward the Mac platform that we just launched. And we are showing that for now, the only service instantiated is this example service. But then after the deployment of the OPC UA server, the service as day 1 operation will register itself. So we will see another service, or at least we hope to see another service here as well. Okay, sorry for the intrusion.
Yes, sir. Thank you, Davide. Okay, so yes, as Davide said, after we launch the server, we register the inside the Mac platform all the endpoints that are needed by the client to reach the service located inside the server. Okay, now I see that the server is building. Sorry, but it is a little bit difficult to do not have the control of the presentation and speaking in front of a screen. Okay, it seems that now the server is active and running. So with the command nslist, we can see, yes, that the server is now ready. And now we can see that the server has updated the host and the port that are the two fundamental endpoints that are needed by the client to connect to the server. Okay, I think that we can go to the client side. Okay, he's launching the client. Okay, let's wait a few seconds for the service that is up and running. Okay, now the service is ready, and now is where now we will show you the day two operation, the day two action that we have implemented. Basically, yes, this is the action. So the name of the action is get node hierarchy. Sorry for the typo in the hierarchy name, but yes, it takes a parameter that is MAC based, and basically it is the ID that identifies service, and yes, and this action show you all the namespace that we have saved inside the server. So now we have launched the action. Now we see if it is completed. Yes, it is completed. Now we can show what is the result of this action. Yes, sorry, it is not a very good output, but this is the entire namespace that is present inside the server. And yes, the second, and we have a second action. This action is used to navigate inside the namespace of the server, and its role is basically to find what are the values that are stored inside all those variables. In fact, we can see some variable like random number, temperature, serial number, and so on. These are all variables that are stored inside the server, and we can get access through this action that is called get namespace variable. And for example, using the index 88 that, as you can see from the upper part of the screen, is related to the random number. So by using that command, we can get the value of the random number variable that is stored inside the 88th position inside the namespace of the server. Okay, now we see if it is processing.
Yeah, unfortunately, we didn't have time to test it through, so I think that there's an error in the output, but
yes, because we have tested it using inside Kubernetes, and the output is the function is working correctly, but we don't know, we do not have time to solve this problem. The output is not shown correctly at this side. Okay.
Yeah, we will probably have needed like an hour or more probably to be fully ready.
Okay, and I think that all for what concern my presentation, and sorry for all these technical problems, and yes, it is a little bit difficult to handle a presentation without having the control of the terminal. So I hope to be clear as well.
You've done great, Lorenzo. Very good.
Okay.
And we're almost back to timing. 1 minute for questions or comments.
I have some questions. Well, first of all, congratulations, because you brought together many interesting topics like MEC and hybrid network. Well, let's say services, because you are using Helm-based and UU bundle. They could eventually be mixed in a slice or something like that. But I would like to understand some things in case I missed something. You're launching a MEC platform. This is a CNF based on Helm, right?
Yes.
That's the first network service. Then you're launching a client and a server. Those are MEC, what would be considered MEC apps. Is that right? Okay. And both are based in UU bundles, both client and server, or just the client?
Both client and server.
Okay. And you're running primitives. Is day 2 primitives in the client?
Yes.
To use the API of the MEC platform?
Yes.
Okay.
We also have a day 1 operation. Let me just add this on the server itself. You should be able to see it here.
Which discovers the service, right?
Which register the server or service, yeah. So
yeah, yes. So when the server is launched, we have a day 1 action to register itself to the MEC platform. So after the service launched, the MEC platform is aware of the endpoints of the server, and all the clients can ask to the MEC platform what are those endpoints to reach the server.
Maybe in this way is clearer. This is like the service list inside the MEC platform before launching the server. As you can see, we only have one service, which is the example 1. And after running the server, so after deploying the server, a day 1 operation is triggered. And if we do the same standardized call toward the list of services of the MEC platform, we see that we have also this server here.
Great. Excellent. Understood. Thank you. Congratulations.